Welcome to the PrepNet, presented every Sunday at 6 p.m. Eastern Time on Talk2Me's Channel 14. Come join us to discuss everything about prepping and hear what others have done. All about electricity. Special video, voltage, amps, watts, and wire size. Since we're having many net sessions on electricity, this is a special video to cover the topic of voltage, amps, watts, and wire size. I have assumed that everyone knows what I'm talking about when I use the terms voltage, amps, amp hours, watts, and watt hours. In addition to discussing the correct wire sizes you need for your electrical backup systems, you also need to consider the following. I sort of remember that I presented an assumptions presentation as one of our topics early on in our prepping series to point out that we should not, quote, assume things, unquote. My bad. So let's see if I can get these terms explained so my other presentations will be more understandable. First, we'll cover voltage. There are two types of electricity: AC, which stands for alternating current, and DC, which stands for direct current. The electricity that comes from your outlet in your house is AC and has a voltage of 120 volts. This is the most common voltage in the United States and runs most electrical items in your house. 240-volt split-phase AC is what is run to your house from the power company. This AC voltage is used for high amperage items like electric ranges, electric hot water heaters, and deep well pumps, to name a few. This voltage is called alternating current, as the positive and negative poles alternate from 0 volts up to 120 volts positive and then down through 0 volts to negative 120 volts and repeats. This is called a pure sine wave and happens 60 times per second and is referred to as 60 hertz. The next type is direct current electricity, where positive is always positive and negative is always negative. There are many common voltages of DC, from 1.5 volts for AA and AAA batteries, 3.7 volts for 18650 batteries, 12 volts for car batteries, and 12, 24, and 48 volts for battery banks. DC voltages can also be created with an AC to DC power supply. This is what happens when you plug in a wall wart into your house outlet to charge your phone. You are using 120-volt AC from your outlet and converting it to 5 volts DC to charge your phone. Now let's talk about amps and watts, which is a measurement of the amount of electricity being used. It's like your fuel gauge on your car. Watts are usually used when measuring electricity used in AC equipment like TVs, washing machines, lights, and refrigerators. As an example of watts, a 100-watt incandescent light will draw 100 watts at 120 volts AC. A 100-watt CFL light will draw 23 watts, etc. To see how many watts your 120-volt AC equipment uses, I would suggest a meter that can measure this. I have put a link in the video description of one of these meters. Amps or amperes are usually used when measuring electricity used in DC circuits or batteries. As an example of amps, one headlight might draw 8 amps at 12 volts DC. A CB radio might draw 3.5 amps at 12 volts DC. Now to amp hours and watt hours. Amp hours is the amount of amps used in 1 hour. An example would be a headlight using 8 amps at 12 volts DC. If that headlight is run for 1 hour at 8 amps, it would use 8 amp hours of power in 1 hour. It would use 16 amp hours if run for 2 hours, etc. Batteries are rated in the total amp hours that the battery can provide. Knowing the total amount of amp hours available will allow you to determine how much electric equipment you can run from a battery and for how long. Watt hours is the amount of watts used in 1 hour and is usually the measurement used for AC equipment. A quick example would be if you ran a 100-watt incandescent light for 1 hour, you would have used 100 watt hours. If you ran that same light for 12 hours, you would have used 1200 watt hours or 1.2 kilowatt hours. When you view your house electric bill, you will see how many kilowatt hours of power you are being billed for. Knowing how many total watts you need to have at one time will allow you to pick the proper size generator to produce that amount of watts. Now, AC equipment shows you how many watts it uses, but your battery bank uses amps and amp hours. Watts and watt hours will have the same value whether using AC or DC electricity or what the voltage is. So the question, Is there a way to convert watts and watt hours into amps and amp hours so you can determine if a battery will run your AC loads? Yes, there is. It is called Ohm's law, which is a mathematical formula. It is often called pi. That's P for power or watts, I for current or amps, and E for energy or volts. To get how many watts are being used, multiply amps times volts. 3 amps times 12 volts equals 36 watts. To get the voltage, divide the watts by the amps. 36 watts divided by 3 amps equals 12 volts. And to get how many amps are being used, divide watts by volts. 36 watts divided by 12 volts equals 3 amps. This last one is how you can estimate how many amps or amp hours will be used from your battery bank when running 120-volt AC equipment through a DC to AC inverter. Here are a few examples, and I will be rounding the amps to a whole number. I have a TV that draws 250 watts at 120 volts AC. This is 2 amps at 120 volts AC. 250 watts divided by 120 volts equals 2 amps. To calculate how many amps that would be used from my 12-volt battery, divide watts by volts to get amps. That would be 250 watts divided by 12 volts, which would equal 29 amps at 12 volts DC. And if you ran that TV for 1 hour, you would use 29 amp hours from your battery. The only measurement that remains the same for both AC and DC is watts. The next example, I'm going to run that same TV at 250 watts, a 100-watt light, and a 30-watt radio at the same time. This totals 380 watts at 120 volts AC. To calculate how many amps, just divide 380 watts by 120 volts, which equals 3 amps at 120 volts AC. But how many amp hours would that be from my battery? Divide 380 watts by 12 volts, or whatever your battery bank voltage is, and you get 32 amps. And if you run that for 1 hour, that would be 32 amp hours of energy drawn from your battery. If you need more clarification on this, please email us with your question. Finally, to wire sizes. The more amps or watts that are drawn through a wire, the larger that wire must be. A good example would be your car. Look at the size of the cable going to your car's battery. It's 3/8 to 1/2 inch in diameter, as a lot of amps are needed to start your car. The size of the wires to your headlights is much smaller, as they draw much less power than what is needed to start your car. Now, for even more confusion, the other thing that you need to consider in the wire size you use is voltage. The higher the voltage, the smaller the wire you need for a given amperage or wattage. A note here on wire gauges. The higher the number, the smaller the size. Here's a quick example. For a 200-watt load at 120 volts, you will draw 2 amps, and using a 10-foot wire, your smallest size would be 19-gauge wire, which is 0.9 millimeters in diameter. To run that same load from your 24-volt battery with a DC to AC inverter, you will draw 8 amps and requires a minimum size wire of 12-gauge wire, which is 2 millimeters in diameter. To run that same load from your 12-volt battery, you will draw 17 amps and requires a minimum size wire of 9-gauge wire, which is 3 millimeters in diameter. Wire sizing is a big topic, and we will not cover it here in depth. I would encourage you to research more about wire sizing before wiring your battery bank to ensure you are creating a safe emergency backup power. I have provided links to wiring calculators in the video description, so check those out. And as a rule of thumb, use at least the next larger size wire than you need. You really shouldn't run the maximum through a wire, as it could heat up. Please watch all of the expanded presentations on All About Electricity in this playlist to get more information, but remember, we are not providing detailed how-to presentations, but only touching on the general topic. If you have any questions about what we have discussed here, please send your question to prepnetch14@gmail.com and enter question in the subject line.